Hello, everyone. My name is Cynthia Wenz, and I'm your host for this episode of SLB New Energy Conversations. In today's episode, we will talk about lithium, an incredibly hot commodity in recent years as it's a key element in the batteries used in electric vehicles. Lithium demand for electric vehicle batteries is not only on the rise, but also expected to grow, which means an increased lithium supply is needed. However, the existing production methods are often time consuming and they have a huge impact on the environment. This raises the big question: is it possible to produce high quality lithium quickly, efficiently, economically, and sustainably? No one better to answer this question than Nicholas Lugansky, SLB Head of Mining, who has more than 27 years of experience in the mining industry and has just delivered a breakthrough milestone in sustainable lithium production. Nicholas, thank you so much for joining us today.
Thank you so much. It's a pleasure to be here.
So let's just start off with this word sustainability. Why is sustainability so critical in lithium production today?
Well, I think you just touched on probably the most important question for the extraction industry and the mining industry. Sustainability equals to social license to operate. Every local community that has an extraction mine somewhere near them are very concerned of the impact of that mine on their livelihood from the standpoint of water, air, land, etc. And so addressing those questions and making sure that your extraction is as sustainable as possible is the key for people to accept you in their community and allow you to bring the technology and then, as a result, resource to the world that we need to build a better decarbonized world.
And is there a sustainable way to do that?
Yes, indeed, and that's what we proved at our Clayton Valley facility. We wanted to make sure that our technology is not only addresses the speed of production, but also addresses concern of water use, chemical use, and energy use, because those things are very close to the communities in Clayton Valley, considering it is in the middle of the desert of Nevada.
And the technology that you use to do that, innovative, nonetheless, integrated, I'm sure, process. So when we talk about innovative technology and we talk about integrated process, what does that really mean? Are you saying when you bring in sustainability and technology, is the technology alone not a silver bullet to effectively and sustainably extract lithium?
Well, I think you covered a lot of very important words, and maybe let me give you an explanation what this technology is. I think for a lot of people, they only hear the word lithium and they don't quite understand what's happening. So lithium is currently exists in a number of forms around the world. It exists inside of water, which we call brine. It exists inside of rock. And so there are very different ways to extract it out of those elements so that we can then put it inside a battery that drives either your cell phone or your car or used for energy storage. What we did is we looked at specifically how can we develop a technology to efficiently extract lithium out of the brines, means out of the liquid form. And we found a location where we could do the test, which is Clayton Valley, Nevada. And our process looks at several stages. Number one, we designed a lot of subsurface solution, being SLB and having a long history in developing solutions for how to find oil and gas, now how to find lithium, how to characterize that lithium underneath, how to extract that lithium, meaning through the type of well that you need to build. And then we wanted to say, how do we take it from well to that battery chemical that we need? And so that's where we took a suite of technologies, because in reality, an operator is not looking just one piece. They want to make sure that they have entire process from well to the battery grade product. And we combined steps such as pre-treatment, making sure that that brine is ready to enter something called direct lithium extraction, and then sub-processes that remove any residual impurity and crystallize our lithium into powder that can be then delivered to battery manufacturers.
And I see now what you mean by integrated. this is that integrated solution, that process. So what you're saying is that we can identify new lithium resources in place by simply understanding the subsurface behavior?
You're absolutely correct. I think, let me maybe just explain. Lithium exists pretty much in every aquifer around the world. The difference is the concentration of that lithium in that aquifer. For example, your water you're drinking in Houston has small traces of lithium, and they're healthy for you. However, a high concentration is not, but it is good for the battery production. So what we did is we analyzed the many aquifers around the world to understand which ones have a high concentration of lithium. Within that, we looked at how do we characterize that lithium to make sure that our clients know exactly where to drill for that lithium, the same way as we would use for oil and gas. That allows them to have access to the best resource that then you can process.
And so I've heard, and just correct me, but I've heard about the evaporation ponds, because you said lithium is present in all types of aquifers and waters. Explain to me how sustainable lithium production that you've mentioned, how do we not need those evaporation ponds? And then you mentioned the production out in Nevada, your plant that you've developed, which is miraculous. How big is the facility for this production process, and how does that offset the old evaporation ponds versus your new Nevada facility? And talk to me about that process.
I think you touched on two things with this. Number one, evaporation ponds, as you said, they take a lot of land, they take a lot of water, and they take a very long time to extract lithium out of that process. And I'll talk about this in a second. Number two is evaporation ponds work only when your lithium concentration is extremely high in your liquid. So as a result, today evaporation ponds are only used in very few places around the world where lithium concentration in natural brine is very high. That is primarily Nevada, as well as the lithium triangle, Argentina, Chile, Bolivia. The rest of the world does not have the right concentration. Our technology addresses both. It allows us, first of all, to only use less than 10% of the footprint, process that brine in less than 18 hours instead of 18 months, with almost no water consumption. We're able to reduce 95% of the water.
But you said 10%, so is that 10%
of the land?
Of the land.
You basically can have a footprint of your plant that is only 1/10 of the relevant evaporation ponds. Number two, as I said, we are able to tap into brines that have a lower concentration because this new technology using sorption-absorption chemistry is able to extract lithium from fairly low concentrated brines around the world. So it not only addresses the sustainability for the traditional methods, but it also opens the world to a lot of, call it non-conventional brines. So if you compare it to technologies we've seen around the world in copper or in oil, we went from a very simple ores or reserves of oil to much more complex over the last 100 years of human history. And I think that's what we're trying to do here in lithium. We're trying to open new locations of extraction of lithium from brines that previously would not have been economical.
And so describe a little bit more about the economical impact of these extractions. Is it time? Talk to me about those pieces.
I think
extraction volume, what
correct.
is it?
I think it's several steps. So number one is the speed to market. As I already mentioned, 18 hours versus 18 months. That's 500 times faster. Number two is the yield, or the amount of lithium you extract from the same gallon of water. The traditional method depends on level of impurities, only extracts 30 to 50% of that lithium that contains in that brine. We're able to extract up to 96%. And as I already mentioned, there's a number of sustainability factors. In the traditional methods, you precipitate a lot of the impurities with chemicals inside these giant ponds that that are sitting in the deserts, and then you scoop them into these mountains of which we call tailings, or basically waste. And so you have not only evaporated water in a very arid environment, you also created contaminated soil that sits for centuries in the middle of these desert environments. What
So
we're
is this
doing,
the traditional method?
Yes.
This is the way it's been done.
it's been done for the last hundreds years. Lithium was invented in late 1800s, and since then we've been using these type of technologies to extract it. What we're doing is we are creating, in a way, a complex chemical facility that uses something very simple. It uses, I would call it, a little grain of couscous that has inside a special magnet that attracts lithium to it. And then we wash that lithium out of that magnet with just water. And so as a result, we hardly use any chemicals. The only chemical is used in the production of that special couscous, which we call resin. And then the rest of the process is really reliant on recirculation of water and heat to make sure that the process takes place.
But does it consume a lot of water?
Because we recycle all the water and able to re-inject that water back to the aquifer, we only consume less than 5% of the water that we extract with the brine of lithium. So our impact to the environment is 95% positive compared to the traditional evaporation ponds.
It's an amazing process, and I love the couscous referral. It helps put it in context for us. But now, if we don't use, let's say, the solar power to evaporate the water, we need to put it in more of a complex system, I'm guessing, yes? So energy-wise, how much energy do you use for that?
Well, I think that's probably the biggest challenge today as we're going from a traditional evaporation ponds to these new direct lithium extraction type of technologies. The direct lithium extractions mean that you're using some kind of a forced methodology to extract the lithium ion out of the brine. And that inevitably replaces the 18 months of free solar energy for something else.
Right.
The question is, how do you make it as least impactful? So number one is we made sure that after we extract, before we concentrate and crystallize, that we use the technologies that are the most energy efficient. And this is where we're unique. We're not using forced evaporators, which are basically using energy we bring into these big, giant, call them dryers, right? Like you have in your house that circulates the water and evaporates it using sort of heat and force. Now we're using specialized type of membranes that allows us to concentrate and remove that water, that allows us then to use that water either in the process or return it to the aquifer. So that was one of the big things we spent how do we optimize and save every degree of heat to make sure that our energy consumption is reduced. Number two, we're looking and working with some other parts of SLB where we're developing technologies that allow us to use solar power, store it, and reuse it during the night. So in a way, we're trying to use as much of the green electrons as possible in that process. Thus, not only, as I said, impacting land, chemicals, and water, we also want to impact the energy balance by using as much of green electrons as possible in this process.
And it sounds like in your recent results of your demonstration project out in Nevada, everything you've explained, you can prove. You have this proven, tracked. Can you share with us a little bit more of the results from Clayton Valley, Nevada project?
Yeah, indeed. I think the Clayton Valley is unique because of its size, because of its complexity, and because it proved the entire value chain, as we call it, from well to product. In Clayton Valley, unlike most of the other technology providers in this space, we decided that building it at 1 gallon per minute is not going to give us scale to prove the importance of that technology. So we decided to build a facility that is 100 gallons per minute, which is 1/10 of a commercial size. Just so for people to understand how large this facility, it's about 30 sea containers in size. So it's a sizable facility to produce that lithium. Still, as I mentioned, it's only 1/10 or even less than 1/10 of a traditional methodologies. In those containers, we have all processes. We actually have a rail well. We then pre-treat the brine, primarily adjusting its temperature and removing a few residual solids like sand or silt that you normally have in all aquifers. That's why all of your water coming to your house goes through some filtration to remove that. We then extract that lithium ion, we concentrate it, and finally we crystallize it, and we have a very pure lithium carbonate powder coming on the other end, which we now send to battery producers to analyze and confirm that the quality of that lithium carbonate is ready to be introduced to the batteries for the world consumption.
And you call that the value chain.
Correct.
Which makes sense, but we see something very different in the news. We see DLE projects in the news, and obviously what you're describing through SLB is very different. So, there's promises out there, and sometimes the public is skeptical. So can you tell me how does this promise to change the lithium production industry versus what we see in the news per your value chain?
Well, I think you're addressing a very valuable concern that public has about lithium production. I think still lithium in the world dominates from the traditional production methods, whether it's evaporation ponds or the rock production, which also requires, by the way, a lot of acid, a lot of water, and environmental impact of actually digging that rock out. Right. So today there's practically no DLE facilities around the world. And so what we're doing is a very new, and it's like bringing a new technology. When the first, smartphones appeared, right, we were not sure if they will be accepted by the public. Today, they are normal things. Same things, I think, with these direct lithium extraction-based technologies. One thing that is very important to remember, that DLE by itself is not a solution. You don't go to...
It's not the silver bullet.
Correct. You don't go to just buy an engine. You buy a car. And we see DLE as an engine of this technological progress. It is very critical, it is very important, but it is as good as other parts of that process that I talked about. And so that's why a lot of the DLE producers are still failing to meet the most important question, and that's the economics. I mean, at the end of the day, technology is not only accepted because they're sustainable, they're also accepted because they're economical. And what we wanted to do in our pilot is to prove that it is economical, to prove that it is scalable, and of course to address the sustainability question so that we have the social license to operate.
Well, you also mentioned the smartphone, and when the smartphone came out, it was pretty pricey. And then as the technology became more commonplace, we saw more reasonable price points. So will that be the same with lithium? Well, first of all, let me congratulate you on the milestone. It's miraculous, and hearing you describe it is so impressive. But apparently we need the holistic process to successfully and sustainably produce the lithium. Does it mean that the lithium price will be higher, or talk to me about the pricing point?
Well, I think you're addressing a question of macroeconomics in the lithium market, which is, I think, puzzles us all. Lithium prices for a long time were quite low because lithium was primarily used in non-battery production. Maybe many of you don't know, but actually lithium was invented as a medicine, not as a battery product.
As a medicine for what?
It was used for a lot of psychological disease, and today It is still used as a common ingredient in a lot of your psycho-based medicines for mood control, depression, etc.
It's a very fun fact.
Yeah, and then it was also used for a long time historically in your ceramics. So your bathrooms, your cups all contain lithium because they make your ceramics less brittle. only in the 50s that we realized that we can make battery out of it and store energy in it. And so since then, of course, lithium has been more and more used in the energy part of the economics. As we're accepting more electrical-based solutions, whether it's your electrical vehicles, whether that's long-term storage, and of course all our electronics becomes battery-operated more and more, we need more of that lithium. And as a result, we saw the price of lithium rising because there is not enough supply in the world. I think based on COVID, based on some other macroeconomic facts, we saw a bit of a slowdown in the demand for lithium, and that has, of course, immediately had an adjustment on price. But the price peak that we saw during the COVID was very abnormal. I mean, we went 800% from normal price to the peak, and now we came back basically to the pre-COVID area. We understand that as the EV gets adopted, as energy storage becomes part of our reality to maintain the stable grid, lithium demand will grow. And I think all major forecasts saying that between now till 2040, lithium demand will be 5 times as much as it is produced today. We're producing a little bit over 1 million tons. We will need about 5 million tons.
So is there an optimum price point for your technology to thrive?
We believe that it's really the cost, not the price, because we are not the producers. So it's a question is how much profit you want to make. But from the price standpoint, we need to compete with the traditional technologies. And that's mean that our piece of production needs to be in the range of 5,000 a ton. Maybe a little bit more for some more complex brine, a little less for some of the simpler brines. But that 5,000 per ton is a magic number that will make these types of sustainable technologies adopted by the lithium producers. And that is what we advertised in our press release, and that is what my team is working to deploy commercially to the world.
You've described such an amazing process. You're brilliant. We appreciate you. You've included the environmental impact, the economic proof point. I mean, obviously justifies a change in such an important industry. I love the vision that you cast for the lithium industry and what we can expect moving forward. Nicholas, your expertise is invaluable, and we can't tell you how much we appreciate the insight on how to sustainably produce lithium. Thank you so much for your time today.
Well, thank you for having me. It's a pleasure to be here.
Thank you so much for listening to this episode of SLB New Energy Conversations.